so welcome to another exciting video. This is chemistry, and in this video, let us understand what is an isomer. So an isomer is actually just a compound, okay, that has the same molecular formula but different structural formula. So let us look at how you can be able to come up with maybe name a particular isomer. Okay, so we have, for instance, we have one of the hydrocarbon called pentane, and pentane, as we know, it has got 5 carbon. Okay, so we have to be able, first of all, to have the molecular formula, and then from there we can now have what is called the structural formula of pentane. Now, how do we know from which class of the hydrocarbon does pentane belongs to or belong to? So this one belongs to the alkanes. So it belongs to the alkanes. How do we know? Because we have to look at the 3 letters in terms of each ending. So this ends with A and E. So when you look at one of the classes of hydrocarbon, we have the alkanes, and the alkanes, all those. So we also look at the ending of alkanes is A and E. Of course, the S just means plural. So this is actually an hydrocarbon compound which actually has got single bonds which are held between the carbon to carbon. Okay, so this one has the molecular formula 5H12. Okay, so it has the molecular formula of what? C5H12 as in this. So now, because an isomer has got obviously same molecular formula but different structural formula. Okay, so when you have this, okay, okay, so this is the normal pentane. Okay, this is the normal pentane. So what this means is that you have to be able to be, make sure that the numbers in the formula conform to what is in the structure. Okay, so you have 5 carbon, 1, 2, 3, 4, 5, and then these carbons are surrounded by, in total, by 12 hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So make sure that all those are confirmed. Now, once you have that, now when it comes to the naming of the isomer, it's just a matter of actually, trying to figure out different ways in which you can actually write this structure or draw this structure. So we can have this structure. So we can have the structure as in, let's see, this. Okay. Okay. So we can start by saying that we do the horizontal 4 carbons. Okay, with in this horizontal way, 4 carbons, and then the other carbon, we can actually get the other carbon and branch it off at this this one. Okay, okay, and then what you do now is you now add the hydrogen. Okay, so now you will now add the hydrogen. So now you can see that this structure looks different from the original structure of pentane. But of course, this doesn't actually mean that the molecular formula is different. It is still C5H12. Okay, so from there now we have to name this is an isomer. Okay. So this is an isomer, we have to name it. So how do you go about naming an isomer? So the first thing that you do is you look at the the chain with more atoms of carbon. So this straight line has got actually more atoms of carbon, and this has how many carbon atoms? 1, 2, 3, 4. So it has got 4 atoms of carbon. So we know that from there, an hydrocarbon compound with 4 atoms of carbon is called butane. Okay, so we have what is called the parent name. So this parent name is actually butane. So we have that one as butane. And now we have to look at this, what is called the substituent. Okay, this part which is a branching off from the main parent carbon, or rather this root. So it's branching off. Now when you look at this one, it has got how many atoms of hydrogen? 3 hydrogen. So this is what we call a methyl group. Okay, so this is a group that is going to determine actually the name of the isomer. So from there now, what to do is you have to count. Okay, at what position from the main carbon chain. Okay, so now what you're going to do now is you have counted the number of carbon, and this is how we came up with butane. Okay, and then from there now, after you have the parent name of the hydrocarbon, which is butane, and then now we go and find out at what number, at what position is this branching off. Okay, at what position from this carbon, okay, is the branch off taking place. So we have 2 ways in which to count the branching off. So you can go from right to left. Okay, and this is how we do it. So this is carbon 1, 2, 3, 4. So if I start from right going to left, then I'll discover that the branching off from the main parent hydrocarbon, okay, is branching off at carbon number 2. Okay, and then you have to do actually, you have to confirm that this is actually the only possible and shortest route, because we have to find the shortest route possible. Now, if I reverse this numbering, then I'm going to have 1, 2, 3. Okay, so if I was going to start from left going to the right, I'll discover that the branching off, this part, is taking off at carbon number 3, or position number 3. So it appears that the shortest route, okay, for us to actually reach faster at this branching off is at carbon number 2. So the direction is from right going to left. Okay, so therefore we have 2. Okay, so now 2 dash. So the 2 is actually tells us the position at which the branching off is actually taken off. Now this branching off, the carbon that is branching off from the main parent hydrocarbon is actually called a substituent. Okay, and this substituent is normally referred to specifically as the methyl group. Okay, so 2 dash. Okay, so this is the name of this isomer, 2-methyl butane. Okay, so this is how you can go about naming this kind of isomer that is derived from the main butane, main pentane as an hydrocarbon. So this is how you can go about naming it. So make sure that you really understand how to go about naming isomers. Okay, so thank you so much for watching. Remember to subscribe, like, as well as share my videos. If you want